Going live. Oh, it says I am actually live. Ah, so I guess it would be good afternoon for people who are watching this in the Eastern time zone. Good morning, people who are in the Pacific time zone. This is evening here in Dresden, and I'm jumping in here. Sorry, I'm a little bit late on this. I had to actually fix the internet. Um, I I'm staying in an apartment here in Dresden, and Ada unfortunately didn't make it to Dresden yet. She was supposed to be here. Uh, she was supposed to be here quite a few hours ago, and unfortunately, apparently, there's some sort of knock-on effects to both the grounding of the 737s as well as some weather issues in Amsterdam, and so I'm not even sure where exactly she is. She and several of the people from her group there at Georgia Tech are actually here for the Eurosys 2019, which Eurosys is the European Systems Conference. And since you're taking an operating systems class, um, if you're actually interested in learning more about what's going on in the systems community, Eurosys is actually one of the good venues to find out more about and to consider. So the conference actually starts tomorrow. Today was a workshop day, and I actually came to give a talk at the doctoral workshop, which was earlier today. So let's see. Since I posted this link late, I suspect there may not be a lot of questions. So I'm going to start by actually hitting the there's a Ada posted about the midterm, and I can ramble on a little bit about this. And I don't actually know exactly what's going on there, since she's going to ultimately have to weigh in on what maps to what in terms of the way that it's set up in Canvas and the answers. I know that I worked through some of these when people were asking questions before, and I'll admit, I always have to look at those and think about them, because it requires that you sit there and you say, okay, well, what should the code look like? And I know there were a number of interesting cases there. So somebody asked, I remember seeing one of these. Somebody asked questions about answers 8 and 9 and the correct values there. And it does look like if you entered, I mean, it's doing string matching. It's not very smart. And it's probably doing string matching in C, no less. So we all know how difficult that is. So yes, if you actually have a case like Alan posted a question here, and he says, here are my answers, and he puts a well photoshopped screenshot up there and shows that he put 9 ms instead of just 9. Obviously, those are the kinds of issues that we will correct. So I'm kind of curious about his answer 9, and I think that in fact that's not a range. I think that that's 0.6 or 0.7 would have worked. And so by putting 0.67, you don't match either one of those two strings. So again, that's one of those cases where, yeah, I agree. If you're between 0.6 and 0.7, then you pretty much have a right answer. But it does suggest one of the complications of using Canvas for the exams. So let's go back and look and see if anybody's asked any other questions, because otherwise I'm not sure what I'm going to talk about. I'll have to do some sort of a song and dance or soft shoe number, as it were. Let's see. So there's no questions in the midterm thread. No surprise there. I guess the good thing is it means that I can keep this short. And I don't even actually know if anybody can see this. So, oh, it says there are 3 people. So there must be somebody else out there. I even have a chat, which normally doesn't seem to show up. And I think it might be because I'm using the new YouTube Studio, for whatever that's worth. I'm going to say hello and see if anybody actually responds back. New, easier moderation. Oh, I can actually delete messages. How exciting. Let's see if there's anything on Slack. Oh, okay. So apparently it is streaming live since I am getting comments from the Peanut Gallery. Great. So as I said, I actually I rented an apartment here in Dresden. And so I'm literally doing an Airbnb type thing where I'm just staying in somebody's apartment. They're not here. It's just me. And so even if you are seeing liquor behind me on a cabinet, it is not my liquor. And I wouldn't presume to drink it. Actually, it doesn't even look like liquor. It's balsamic vinegar and oil. And okay. So that was exciting. Oh, look at that. Somebody actually said hello. So the chat actually seems to work in this new YouTube Studio thing. So that's actually an improvement. So if you have questions, feel free to sprinkle them in there and I might actually see them. If not, please feel free to post them on Piazza or even in Slack. Although if you're going to do it in Slack, do it in, I'm looking at the general channel right now. So do it in the general channel and I'll kind of watch it. Or if you want to do it in the coffee channel, for instance, at least tag me. So I'll get a notification from Slack that there's something waiting for me. So let's see here. Yeah, this is going to be a real short one then, because I guess I could talk about Project 3. So Project 3 is well underway. It is due next weekend. Is that right? I think it's next weekend. Better be careful before I create a huge panic. Let me go look. Project 3 is due March 31st. Yes. So that would be the little tiny part of March 31st that overlaps with April 1st in almost everyone else's time zone, because that is AOE time. There is not going to be an entry on Canvas for Project 3 until after the Project 3 due date. We're only going to use Canvas to return the actual Project 3 scores. Let's see. One of the things that I saw a couple of people expressing some confusion about, and so it's probably worth talking about, is the who controls what discussion. And I'm not reading the README file right now. I'm not trying to overparse text. I'm going to explain to you the larger model of what the project is trying to do. So what we have you building in part 2 of Project 3 is a cache, and we have you working with the server. Now, in part 1, we just had you do the proxy server and have it talk to the actual web server. Now, proxying by itself can be useful. So, for example, we can use that to bounce messages so it doesn't look like it's coming from us. That's one use of a proxy. It hides our identity. If any of you have ever used a firewall, the network address translation layer, NAT as it's usually referred to, is a technique by which we take inbound connections and then we map them to outbound connections, typically between a WAN and a LAN. There are other possible uses, but that's the most common configuration. And the idea is that everyone out in the real world on the WAN side thinks that they're just talking to one device, because at some level they are. And everyone on the LAN side is a separate device or separate computer. So what we're effectively doing is we're multiplexing multiple connections through the gateway, through the firewall, and that is a proxy. That's exactly what a proxy does. It says, I'm going to take that request and then I'm going to satisfy it by doing something else. I'm here in Dresden, but I actually have my my firewall set up at home so that if I need to connect to my home desktop system, which is my Linux box at home, I can actually just use SSH. So I have certificates set up. I can use SSH. I have dynamic DNS, and that means that the current IP address that my WAN device at home is publishing to the internet is showing up in DNS because there is an agent that registers what that address is to make sure that I can SSH. That's a proxy. In this particular case, it's actually a fixed mapping proxy because the connection comes from my machine here in Dresden, my laptop, to my gateway at home. And then it in turn creates a separate connection and it sends the message to my desktop system, my Linux system at home. And now all the messages that go back and forth between me and my desktop are actually end-to-end encrypted because this is going through SSH. But the packet that comes in for SSH, which doesn't come in on the standard SSH packet port either, because I'm trying to be minimally secure there. But that packet comes in on a different port and then gets translated to the correct location it's supposed to go to. And this is all done transparently to the actual applications. The SSH daemon on my machine at home and the SSH application on my laptop do not know that they are going through this intermediate process, this intermediate proxy. And this all hangs together. So when we look at Project 3 Part 1, what we're doing is kind of the same thing, except we're doing it with our super simple web server protocol, the get file protocol. Now, at one point, the Project 1 and Project 3 get file protocols were actually compatible, but I don't know that they are 100% compatible. So you may not be able to use your Project 1 client with your Project 3 proxy server. Okay, so part 1, proxy server. Yeah, that's why we give you a separate client, because we know that client works with that protocol. Part 1, we use a download client that's supposed to be the same as the Project 1 client, and it's close. And it then connects to your proxy server. And what your proxy server does is it says, I don't actually have any of these files. I'm going to go get it. And that's what makes it a proxy. It's standing in on behalf of the remote server. Now, we keep this really simple. We don't give you multiple remote servers, but in fact, the correct way to think about this is, how would I use this if I were building that NAT firewall type approach? I want to hide the fact that there's one client talking to multiple servers. So the client talks to me, I talk to the servers, and it's all transparent to the client. We do that kind of thing because it helps, in some cases, it helps protect us. That's why we do that with NAT firewalls. In the case of networking, and particularly in web server cases, if I have 10,000 clients sitting behind a proxy server, it turns out the proxy server can actually cache things so that when we see a request from a client for something we just got for somebody else, we can just give them the copy that we downloaded and saved. And that's going to be our motivation for part 2, but we're going to get there in stages. Part 1 is just about proxying. It's, how do I get from my client to my proxy server, the thing I think I'm talking to, that's our simplified web server, and then it goes and it actually does talk the real HTTP protocol over to the web server. So we've actually got a slight protocol translation going on there. We take the get file protocol and we translate it into the HTTP protocol by using the curl library. How cool is that? We don't ask you to talk to more than one web server. There's no reason we couldn't. We just have to actually have more than one web server for you to talk to. And basically it's the same level of work. But in the real world, you would do this so that a single client could talk to a single proxy, which then talked to multiple potential servers. Okay, so now that sets things up for part two. Part two is where we add the cache. But we try to keep things really simple. So what we actually say is, okay, let's just focus on the cache side now. Let's ignore the fact that in part one, we did all that proxying over to the AWS server, because getting all the way into cache, pulling things, downloading them, putting them in the cache, that actually gets pretty complicated. So we'd like to not overcomplicate this project, because part two is a lot trickier than part one. Part one, fairly straightforward. Once you figure out what proxying is going on, and there are a couple little tricks, like the fact that you can actually do that without saving the file into memory or saving it to local disk. And I mean, one of our goals with this project for a while has been to actually do a very large file transfer with it, specifically to blow you up if you try to save everything into memory or onto disk. It turns out that the test harness on Bonnie actually generates the content of the files in a recoverable fashion, so that we don't actually have to store any of it. We can just, it's just a big hash stream cipher, and we can just compute it. So we know what the name of the file was. Each side knew that. Each side can then use that as a starting point for a. It's not pseudo random. It's actually just a hash that you can iterate over and get different data. So you get streams of data, and that's how it makes it really easy for us to do that. But we haven't done it yet, so that'll be fixed in the next release. All right. So again, trying to keep this simple. We have client talks to proxy. Proxy talks to cache. Cache. And you'll notice that we don't talk to the HTTP server in this model. We don't store anything in that cache. If we were building a full-featured proxy server with a cache, we would do that. And so we have this model where we say we want the proxy to own the shared memory and the cache to own the interprocess communications mechanism. So the idea is that we have a cache. The cache advertises that it's providing caching services. We do that through some sort of well-known name. We have shared memory, and we let the proxy control the shared memory, because the proxy is the one who's going to actually be transmitting the data out to the client. But how does the proxy tell the cache how to get to and connect to that shared memory? Well, we do that through the control path, through the interprocess communications path that we're talking about. Okay, now is where the terminology gets a little fuzzy, because gee, shared memory is a form of interprocess communications. We want you to use shared memory from proxy to the cache, because we think that understanding how shared memory works is an important learning objective. So that's why we insist on that. That's why we're actually saying you must create these segments in the proxy, and you must then tell the cache server about them so it can then use them. So the logical model is proxy server sets up those cache buffers in shared memory, and you can do it. There's basically two ways you can do it. One, you can sit there and you can call mmap as many times as you want to create that number of segments. Or you can just simply say, big mmap, now let's cut that big buffer into small buffers. We're fine with either one. Either one of those is a perfectly acceptable model for doing that, as long as your proxy server and your cache server agree on how you transmit that information. Because remember, the cache server must also do an mmap on its side in order to talk to those buffers. So the cache server comes up and it says, I'm going to use Unix domain sockets. And so it creates a Unix domain socket. It uses a well-known address because we need to know something here. There's other ways we could do that, but this is how we're going to do it in this case, and that's generally what people do in this project. They pick a well-known name. So we have the well-known name, and then the proxy server comes up, and it looks to see if that well-known name is available. Nope, not available. Oh, the cache server must not be running yet. So I don't know. Let's see. I got time for coffee. And so you wait, and then you check again. Is it available? Nope. All right. Well, time for more coffee. I'll probably be getting jittery after a while here. But eventually, the cache server starts, and I say, aha, now I can tell you I want something from you. And so you can send a message to the cache server that says, hey, cache server, I'm the proxy. I want to consume your services. Here's my information so you can also use the shared memory that I set up. Life is good. The cache server then gets that information, initializes its state. Now the cache server calls mmap or shamat, depending on whether you're using System 5 or POSIX, and it maps that memory in based upon the agreement between the proxy and the cache server. And now it can actually start to communicate. So now the proxy server sends a message, and now where you put that message is actually very much up to you. You could continue to use the Unix domain socket that I just hypothesized. Maybe you didn't use Unix domain sockets. Maybe you used message queues are very popular. So you have a message queue, and maybe you have message queues both directions now because, of course, you send a message and then you send a response. And it's really hard to get that to work right on a single message queue. I've seen people do it. It's usually not a lot of fun, but feel free to do that. I mean, honestly, when I did this project, I did it all with shared memory because I know shared memory is really, really fast and really efficient. So all I had to do was say, yo, cache server, here's a big chunk of shared memory. We'll be doing our communications through that. And then I sliced it and diced it. I had a communications area. I had a buffer area. Those were my segments, each one of those segments. I separated things out. I had an entire ownership model. I actually was very careful to avoid using mutexes and condition variables because I didn't want to do that if I could avoid it. And so there was a clear state machine that showed the ownership. But that's really complicated. So the easy way to do that is to just simply say, you know what? I'm going to have some mutexes and condition variables, and I'm going to stick them in the shared memory. That's pretty easy, and it's straightforward. But you don't have to do it that way. You can do it with message queues. You can do it with semaphores. That's one of the fun things about this particular project, but it's also one of the challenges about this project. You need to make decisions, and this shirt is something that really should come to mind. Let me go look. I'm actually looking at Piazza, not at what the camera says. So, weeks of coding can save you hours of planning. Oh, and look, someone asked me to talk about Project 3 Part 2. Wow. Okay, so which is where I'm at right now. You need to plan. You need to sit down and you need to say, this is what I want to accomplish. This is how I want to accomplish it. And that's an important thing to keep in mind with Project 3 Part 2 in particular. There isn't one right answer. And this is a very common problem in systems. And I literally just got done doing my presentation at the doctoral workshop today. And that was one of the things that I actually used as a point. I had one of the senior people in systems from Google sitting there in the audience, and he's going, well, we already store these relationships. So you want us to store all these relationships? And I said, well, that's ridiculous. I said, we don't do that for anything else. If we want to push it to ad absurdum, then yeah, okay. No, but what we want is we want I'm arguing that there might be some place beyond that that we should actually look at and see if maybe storing additional information about the files in our file system would help us solve this particular problem, which kind of actually convinced me that he sort of saw maybe there is a problem worth considering, because he was a big critic of the work that I've been doing. So my point, to get back to what I'm saying here, is in systems, we often realize that we have a continuum and we explore the space in the area of that continuum. And you've seen just a little bit of that in some of the papers. One of the people who presented today was talking about scheduling on multi-core Intel processors for AVX 512 instructions. And I laughed as his poster was set up next to mine, and I laughed and I said, wow, that's pretty crazy, because that looks exactly like Sasha Fedorov's work, where you guys have read that paper. So all we're doing is really trying to help you understand that this isn't a cookbook. This isn't I sit down and I follow a series of instructions. This is I have a dozen tools in my tool chest, and I need to pick the best tool to solve this particular problem, or I need to pick some tools to solve this particular problem. How do you know which one's the best? Odds are you probably actually have to do it multiple times and figure out which one solves the particular problem best. And then what you're going to learn is that we swap the problem on you, the solution that you used isn't the best anymore. And so that is a really complex part of what we do in systems. And this is just a little tiny taste of that problem space, of the fact that we give you these set of tools and you have to actually decide how you're going to use those set of tools. So let's see. So now let's see. Uh, our award-winning TA said, "Who wants to plan?" This is great, actually, being able to read comments on the side. How about only using message queues and accessing the message queues in both ends at the same time and observe if there's any message on the queue? Well, that sounds like the one message queue bidirectional communications plan. And yes, that is kind of like two people getting on the phone and both talking at the same time. You can make that work. Um, But I can't say don't do that. I'm just simply saying that most people find it easier to set up two message queues, but you can set up one message queue and make it work. There are mechanisms for doing that. So if proxy wakes up first, and it can queue up the requests on the message queue, and when cache wakes up and process queue items, is this an acceptable solution? If it works, it's acceptable, except from the perspective that you said only use message queues. Now, remember, I said we do have a hard requirement that you have to use shared memory from the proxy to the cache to get the data across. So if I qualify this by saying only using message queue to send control data across, the answer is yes, you can do that. And it's not uncommon for people just to use message queues. You don't even actually need to use synchronization then. You can do an ownership model where you transfer ownership through the messages that you send back and forth. You don't need to use condition variables or semaphores or mutexes or any of that stuff. But you're effectively doing the same thing. I mean, that's the other interesting thing I find about this, is that all of these tools have slightly different performance trade-offs, but in the end, the designs are more similar than you would expect them to be otherwise. So let me see. I'm going to go back and look at Piazza and see. No, still no questions. I'll refresh it just to make absolutely sure. So no more questions on Piazza. I don't know if there's anybody. There are 4 people watching, so this is definitely a short one. Oh, we get a new question from Richard. Let's see. Does the GFS server in this case is multi-threaded by default? All right, hold on, because there's another question again. So, does the GFS server in this case is multi-threaded by default? I'm trying to remember. I think it's thread safe, but I don't think it actually does any multi-threading. I think it just simply, it's just an implementation of GFS send. You're sending context into it, and it's sending data back out. But I'd have to actually look to confirm that, because I honestly don't remember. If you want me to verify what this actually does, let's see if I can find it quickly here on my own machine. This is one of the reasons that I have to be able to SSH back into home, is that I don't always have the code with me. Let's see here. Make sure I have the current code. Who cares? It's not that bad. It wasn't the current code. So yeah, great. My local copy is different. Oh, look, it's got the Windows mode trick. All right, I'm not going to deal with that then. So I'm just going to go look at the code and see if I can figure out what it's actually doing. This is PR3 proxy cache. Oh, you asked if the GFS server is okay, right? Yes, so you're asking about the. Why did I not like that? Because fortunately, my brain doesn't multitask as well as I'd like. So my brain and fingers need to be able to run at the same time. Be sure the server then. Let's see, what do we have? Yes, it has a worker. And it pulled, yep, yes. So yes, the question was, is the server engine multi-threaded? And the answer is yes, it is. It's pretty much the same model. I mean, the code between projects 1 and 3 were at one point shared, and what's happened is that they've diverged. Unfortunately, just a little bit. So yes. So no worries, Richard. All right. So Bullet has another question, and it is a question on 2:13. When I first saw that, I was like, I thought maybe it was a biblical reference. So I'm not actually sure. What does 2:13 mean? Oh, 2:31 p.m. Okay, I don't actually have timestamps. Let's see. Can I turn timestamps on here? Toggle timestamps. Yes, I can. Woohoo. Okay, so let's see. 2:31 would be. Now, this is great because my laptop is actually on Pacific time. I'm currently in Central European time, which is, they haven't started daylight savings time here yet. So let's see. So 11:31. I have another question on 2:13. I was asking shared memory related. Let's see. 2:31 p.m. I'm not sure. I'm trying to figure out architecture. I created multiple Schmids. Okay. I see. It's at 11:13. And of course, since all the times are relative to the time zone. Okay. I think I understand what you're talking about now. All right. So you asked, I created multiple Schmid and using it on messages so cache can Schmid to write data and send back messages when it has finished the writing data. Okay. So one of the approaches, I think that what you're doing is you're actually creating a shared memory blob for each data transfer. And in fact, we really need to add a test for this, because that isn't actually isn't a good model. And One of the reasons that this isn't a good model is because while shared memory is really fast once it's set up, it turns out it's actually quite an expensive thing to set up and tear down. Um, it requires multiple calls into the kernel. We have to modify page tables, and when we tear it down, we actually have to send a broadcast message to every processor on which that process is currently running, in order to invalidate uh, invalidate the TLB correctly. So let's see. So Bulent, I hope I'm pronouncing your name properly. I'm creating multiple SH segments. So SH, I hope you're not meaning like shell. I'm assuming you mean shared memory segments there. I am creating multiple shared memory segments. Okay, well, so the project says, and you're sending a shared memory segment ID between proxy to cache. Okay, so in your cache, are you mapping and unmapping using the segment ID each time, or are you just are you saying, have I seen this before? Yes, I have. Okay, I'll use the pointer I have for it. No, I haven't. Okay, I'll map it. I mean, I'd be okay with that one, but you don't want to set it up and tear it down for each block that you transfer across, just because that's a high overhead activity. I know there's a lag because, of course, I'm sitting here going, "Yeah, okay, I've answered. Now where's the follow up?" I'm creating it only once. Okay, then that's fine. That's not a problem. Yes, reusing the shared memory buffers is exactly what we wanted you to do. So, how you get it mapped, you're doing it a little more dynamically. That's great. One of the things that is a little tough about this particular project is there are so many different ways for people to do things that it's hard for us to detect to automatically detect that you're doing everything the way we want you to do it. And we try. That was one of the big projects I did on Bonnie, was actually changing the test code to look for leaked interprocess communications calls, which when we're done with this, that will give me another topic to discuss, which is one of the side effects of the way that we actually test on Bonnie here. Okay, so Bulent looks like he's happy, and that gives me permission to talk about the way that things get tested on Bonnie for Project 3. So we are using a container model. Now, the container model is built on top of this idea that we're going to use separate environments for each time we run your program. And so we we create a new container environment. And what the container library does, it proxies actually. It maps between services in the underlying operating system and services that it's providing through the container interface to the stuff running inside the container. The goal is to make things running inside the container look like they are only running on a machine with just that program. Nothing else. No other programs. If you actually start up the container and you look at it, it will literally show you that there's just an init process plus your shell, and if you're running any programs, it'll show those programs, and that's all it will show from a PS. But underneath that, those are actually threads running in the real operating system. So what's happening is the container model is mapping between the real operating system services and the services inside of the container. So each time you start up, we create a brand new container, but each individual test within a given test run is in the same container. So we don't have a completely clean environment after each test. And so one of the complications with Project 3 is that sometimes if things go wrong, like you don't clean up uh, IPC resources, it impacts subsequent tests because your tests aren't written to handle that case where a previous run of the test failed and the resources didn't cleaned up. So one of the things that you can do often to help with this particular problem is say, what happens if I just kill my test in the middle and then restart? Do things work? Do they not work? Um, a flip side of this is make sure that when you start up a brand new clean machine and you run, that everything works right. I noticed that somebody posted on Piazza yesterday, or the day before yesterday, that they were having a problem with Bonnie, and then they rebooted their own machine and they started having the same problem. And it was because some IPC resource at some point in their development, uh, they ended up creating that IPC resource and then they stopped creating it. But because it still existed, they kept using it. But then they ran it on Bonnie. The broken code had never run because this is a clean container, so it didn't have any vestiges of a prior run, and it wasn't there, and it failed. And then they rebooted their machine, and it wasn't there, and it failed. So yeah, that's kind of the flip side of this is that because we keep running on the same machine, sometimes the issues from prior runs or the things we did in prior runs impact the current run. And so that's something for you to keep track of and be aware of as well. We try really hard to clean things up on Bonnie, but I have seen cases where even though we're doing sig kill, it doesn't actually die, and that might even be a bug somewhere in the container library. Because remember, the container library is doing all this fancy mapping back and forth, and there are cases where you can have threads, kernel threads that are in certain conditions where they won't take a signal because the signals are masked, they're disabled in the kernel, so they can't even return it back up to user mode. They don't kill the thread, because we try very hard to clean things up. We might be able to try harder on the IPC front, but I'm not sure. I haven't convinced myself that's actually the right solution, because it's perfectly reasonable to expect that your server might fail and it might get restarted, and it should be able to handle that particular condition. That sort of thing happens. You're sitting there doing development, you get annoyed at your server, and you say, die. You type kill -9, and poof, away goes the server with no notice, no warning, no signal handler, callback, nothing. And now you're left with a bunch of detritus, the IPC that you created from the previous call. Another observation that someone made was that they were using, I think, System 5 shared memory, and they were getting a shmid of 0. And I actually went and looked this one up when I first saw it, because I said, that's really weird. But it turns out that if you actually look at the System 5 specification, it says that 0 is a valid shared memory ID. The problem is that the call you have to pass it to wants a value greater than 0. So the usual solution I suggest for people who use System 5 in that particular case is, great, now you've learned that there's a hole in the specification. Close the shmid 0, get rid of it, and create it again as shmid 1 and use that, because those numbers just go up sequentially. It's shmid 0, 1, 2, 3, 4, 5, so on and so forth. Underneath, none of that's really happening because the actual shared memory ID inside of the OS is some other number, but it's getting mapped to 0 by the Docker library because it's proxying these requests for you. Don't you like how this all dovetails together? How we see these concepts occur repeatedly in systems. So I'm going to go back now and I'm going to look at Piazza and refresh it, and nope, nothing there. Let's see. So I've been rambling for a while here. Let's see. No more questions in the chat. We're 44 minutes and 6 seconds into this. So let's see, what else can I talk about? It's kind of gray and drizzly here in Dresden, and perfect weather for staying indoors at a conference on operating systems. Ada and her team actually have a paper here at at the conference. Here, let me go get that. EuroSys 2019. Yep. So let's see, program, conference program, accepted papers. So I'll actually post a link to this because you can go see the actual paper that Keton, who's one of Ada's students, one of her PhD students, will be presenting on Wednesday. The conference runs through Thursday, early afternoon. But it's all machine learning papers at the end, I think, if I remember right. So I'm going. I'm just after the conference ends. I'm heading to Madrid, and that's actually taking a little bit of time off. So let's see. So yeah, I'm gonna post this link just so you can actually go and look at it, and you'll see that there are systems is a very broad field, and the things that are discussed here are pretty interesting, pretty different from each other. Things about encryption and conclaves, which are a big issue in multi-tenancy. In other words, when we stick multiple users from potentially hostile users onto the same hardware, how do we protect them from each other? How do we make sure that I can't affect your business function? So I'm going to post that link. So those are the papers. There's other links on there as well. So there we go. Let's see. Let's see. Why not? I'm actually looking at Slack now because 37 minutes ago, someone said they have questions, and then our award-winning TA, who shall remain nameless, but he's happy to introduce himself as the award-winning TA anytime you ask. Our award-winning TA said, you can't ask live questions anyway. And I was like, really? Seems to be working. Well, mostly live. All right, let's see. Did I already address the port binding errors in Bonnie? Yeah, I actually did discuss why that happens. So the Bonnie proxy and cache servers talk to each other over a port. It starts with port number 8500. If one of them doesn't die in the prior test run, then port 8500 will be in use. And I think the script actually then goes to 8501, and things just get bad after that. So normally it's a secondary failure, and my usual suggestion is, in order to fix that, you want to look at the test that doesn't have that failure and fix that if it's at all possible, because it is actually causing the knock-on effect, the secondary failures. Let's see here. This is up here. Blah 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 da da da. Hash. Yes. So it literally has a little function that starts at 8500 and then incrementally looks for an open port numbered above that, and then it passes that in as the port to use for the test. And so that's why you're seeing, if this happens multiple times, you'll see 8500 and then 8501 and then 8502 and so on and so forth. So the answer is, look at the first failure. So yes, Daniel, it is something going wrong in your code that is that it means that the proxy or the cache isn't exiting, either because they're both using the same port number to talk to each other. That's how they do a secret handshake back and forth to compare data when we're actually doing the testing. Let's see, what else do we have here? Clarification. Thanks for office hours. All right. So no worries, David. You're welcome for office hours. I'm going to make one more pass here, see if there's any more questions, and if not, I'm going to let you guys go do something useful. So, all right. So no more questions. No questions on Piazza. Let's look at. Yes. Thank you. Multiple award-winning TA. Just in case anyone was surprised by that. I don't want to break his heart, but there are other multiple award-winning TAs in the CS 6200 family. But that doesn't necessarily mean that he's not deserving of every single one of those. And if you have found that he has helped you, then, oh, you're very unique. He's sitting there saying, "I'm not unique on Slack." You're very unique. Let's see. In fact, I'm going to put the link for how he gets. There's actually a website for it. How crazy! Yeah, there it is. All he does is verbally berate me in a constructive way. So here, I'm going to actually put the link here and on YouTube, and I'll even put it on Piazza. Now I'm posting the link on Piazza. So it's a web form. You fill out the web form, and then they send him a paper certificate saying, "You are absolutely wonderful. Here is your paper certificate," to that effect. All right. Let's see. Can I comment? Oh, and then Sergey jumps in here. There's always somebody. Last moment. 1319. I mean, I have to admit, I try to answer. Really? Okay, so let's pretend that didn't happen. It decided to start up Firefox and install updates to it. So, fortunately, I'm using Chrome to run YouTube Live. This is about the update from March 6th, so 19 days ago, where we fixed the incorrect file name for part 2, proxy student h instead of cache student.h. Somebody complained about that, and I looked at it and I said, okay, well, we have to fix one or the other. So I changed the file name and updated the repo. But in fact, as the student answer was, I changed the names manually. And yes, if you rename the name manually, that's pretty much all it takes. Sam was asking if he doesn't get pull upstream master, will that cause conflict? It shouldn't, but unfortunately, like all things with Git, your mileage may vary. I would strongly suggest that if you're going to do a pull like that you make sure that you have everything already checked in, and so that you don't have any pending changes. Everything's been committed and you have a clean repo, and then do the pull. And then if things go bad, you can at least undo it. Or if you're particularly paranoid, you can do the pull into a separate branch and then merge your changes into that branch and then see if the merge works correctly. And if it does, then you can move it back into the master branch. And I've done that in cases where I'm doing multi repository branch merging, because I've made changes to a particular repository that I forked at a certain point in time, and then that repository moved forward, and now I need to move the changes in, and I don't want to break mine, so I move them into a different branch, make sure the merge works correctly, make sure that works right, and then merge that back into the master branch. So that is another approach to use as well. Um, but it was just a rename. So you can also just rename it. Get move, I think it is. Get move, get rename, which if you actually just do an MV command, it will turn into I think it's a get delete and a get add, and then Git figures out that it's moved it and turns it into a rename, because it merges those two operations into one. It's kind of complicated for something that seems pretty simple. All right. We'll make one more round since we didn't make it through that time. So check. Why do they have to give me pop-ups? Okay, there we go. Let's see. All right, so there's nothing else on YouTube Live and Slack. And then Sergey saying something. Proxy student -h and proxy student.h are both in the script. Yeah, okay. I'm not sure. I think that's just a statement. Oh, right. I think, okay. I think Sergey's point is that, is that in addition to renaming it, you also have to update the submission script. And if you have to update the submission script, there is this really cool thing called Git cherry pick. And here you go. This is a cute command. I will put that here. I will put that in YouTube. If I can find it again, here it is. And I will put it on Piazza. Because having 3 different communications channels can get to be a bit much. I'm adding that to Piazza as well. So let me go back to 31.13.19. Cache student update. All right, I don't need to keep you guys on here while I add this to the answer here on Piazza for 1319. So I'll check one more time. I can't check Piazza. Yes, okay. All right, so I think Sergey's all squared away. And do we have any more questions here? Nope, okay. There we go. All right, so I think that's it. Thanks very much, and good luck with finishing project 3.